Good afternoon, everyone.
Good afternoon, sir.
Today we shall learn a new chapter, distribution of oceans and continents, chapter 4 of your NCERT textbook, Fundamentals of Physical Geography. Now I will present. Chapter 4, Fundamentals of your textbook, Fundamentals of Physical Geography. The name of this chapter is Distribution of Oceans and Continents. You have learned that continents cover 29% of the surface of the earth, and the remainder is under ocean waters. The position of the continents and the ocean bodies as we see them in the map have not been the same in the past. All of you, I think, are familiar with the world map, and the positions of the continents and oceans which you are seeing today have not been the same in the past. And moreover, it is now a well accepted fact that oceans and the continents will not continue to enjoy their present positions in times to come. That means the position of the continents and ocean have been changing, in due course of time. So the continents are not stable, these are unstable, changing from time to time. So if this is so, the question arises, what were their positions in the past? What were the positions of the continents in the past? Why and how they do change their positions? Even if it is true that the continents and oceans have changed and are changing their positions, you may be wondering as to how the scientists know about this. And so you'll find the answers of some of these questions in this chapter. So to understand about the positions of the continents and oceans in the past and the present, we have to read carefully this theory known as Continental Drift theory. Let us read. Observe the shape of coastlines of Atlantic Ocean, and you will be surprised by the symmetry of coastlines on either side of the ocean. So here is the world map. So analyze, observe very carefully the coastlines of Atlantic Ocean. See. Here, this is North Atlantic Ocean, this is South Atlantic Ocean, and they analyze the coastline, and it is symmetry. See here. Here it takes the shape of S, and here on the eastern part also it takes the shape of S. That means it is parallel. Both the coastlines are parallel. That is, we have got the symmetry. Just see here. Here, this is the coastline. And here we have got this. So it is almost parallel. So it is symmetry in nature. And no wonder many scientists thought of this similarity and considered the possibility of the two Americas, Europe, Africa, to be one joined together. Many scientists thought of this, of this similarity and consider the possibility of two Americas, Europe, Africa to be once together. Again, let us see the world map. That means these Americas can be fixed here, and these also can be brought here, and Australia also can be brought here. So in this way, two Americas then can be fixed with Europe and Africa, and Australia can be brought here. Okay. From the known record of the history of science, it was Abraham Ortelius, a Dutch mapmaker, who first proposed such possibility. Okay, as early as 1596. So this Dutch mapmaker, Abraham Ortelius, okay, first proposed such possibility of this fixing of these continents together, okay, of the joining of the continents together. And Antonio Pellegrini drew a map showing the three continents together, that is the two Americas and Africa together. However, it was Alfred Wagner, a German meteorologist, who put forth a comprehensive argument in the form of continental drift theory in the year 1912, and this was regarding distribution of oceans and the continents. Now let us read, okay, about the continental drift theory. According to Alfred Wagner, all the continents form a single continental mass and a mega ocean surrounded by the same. The supercontinent was named as Pangaea, which means all earth. The mega ocean was called Panthalassa, meaning all water. Okay, so it was in this way. Let us say this is the earth, and according to Wagner, okay, there was only one continent, a big continent known as Pangaea. Okay, it was known as Pangaea, and it was surrounded, okay, by a big ocean, okay, known as Panthalassa. So there was a supercontinent named Pangaea, and it was surrounded by a big mega ocean known as Panthalassa. And he argued that around 200 million years ago, the supercontinent Pangaea began to break. And Pangaea first broke into two large continental masses known as Laurasia and Gondwana, forming the northern and the southern components respectively. Okay, in due course of time, the Pangaea started breaking into two parts. Okay, here in this way, here the Pangaea was broken into two halves. The one in the northern one, okay, see here, the northern landmass was known as Laurasia, and the southern one, this one, okay, the southern was known as Gondwana land. See here, the supercontinent Pangaea began to split by 2000 million years ago into two large continental masses known as Laurasia in the north and the Gondwana land in the south. Okay, and subsequently Laurasia and Gondwana land continued to break into various smaller continents that exist today. So this is about the continental drift. Okay, see here. So eventually, see this Pangea was broken. Okay, so it was broken into many pieces, and it was drifted. Okay, it was moved to different directions, and thus forming the present continents. So this is what we call continental drift theory. So here let me show you one diagram. See here. So this was the Pangea, and all the continents were joined together by 225 million years ago. Then in due course of time, this Pangea broke into Laurasia and Gondwana land, and again by 150 million years ago, then 100 million years ago, then this Gondwana land and Laurasia broke into smaller pieces, okay, moving in different directions to form the different continents. And see, this is the present arc. Okay, here we have North America, South America, Europe, Africa, Asia, India, Australia, Antarctica. So in this way, all the continents of the world were formed. This is what we call continental drift theory. Okay, so how the continents were drifted, see, just watch one very short video clip. So in this way, the continents were spread in different directions. Any question from your side, boys and girls? Actually, the video was not playing properly. It was boys and girls, did you watch the video? Did you see the video?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay, it was not played properly. It was lagging. I think my computer was hang from time to time, and that is why. Any question from your side? Regarding the continental drift theory? Okay.
No, sir.
Okay, if you don't have, so let us proceed. Now let us learn evidences in support of the continental drift theory. Okay, so we have so many evidences in support of the continental drift theory, because it is one of the most widely accepted theory about the moving of continents. So the first important evidence is the matching of continents. It is known as Zigsaul Feet. Let us read. the shorelines of Africa and South America facing each other have a remarkable and unmistakable match. So the shorelines of Africa and South America facing each other have a remarkable and unmistakable match. Okay, just you will see here. So in this way, South America and Africa can be matched. Okay, in this way. And it may be noted that a map produced using a computer program to find the best feet of the Atlantic margin was presented by Bullard in 1964, and it proved to be quite perfect. Matching of the South America, then with Africa, then North America with Europe was quite perfect. Okay, and the match was tried at 1000 fathom line instead of the present shoreline, because actually present shoreline has been eroded by the sea waves, and so they tried to join all the continents at 1000 fathoms below the sea, and found this matching perfect. Okay, you know, fathom actually is a unit of measurement of depth of the oceans. Okay, fathom is a unit of measurement of depth of the oceans, and 1 fathom is equal to 1.8288 meter. 1 fathom is equal to 1.8288 meter. And next we have these rocks of the same age across the oceans. So this is another evidence. Radiometric dating methods developed in recent period have facilitated correlating the rock formation from different continents across the vast ocean. So what do you mean by this radiometric dating? So radiometric dating measures the decay of radioactive atoms to determine the age of the rock, okay, of a rock sample. Let me repeat. Radiometric dating measures the decay of radioactive atoms to determine the age of a rock sample. You know, these radioactive elements are unstable. Okay, radioactive elements are unstable, and the process by which an unstable atomic nucleus loses energy by releasing radiation is called radioactive decay. Okay, how much the radioactive elements are decayed is used to measure the age of the rock, and that is known as radiometric dating. Okay, and see, it was very useful. Radiometric dating was very useful to determine, okay, the rocks of the ages of the age of the rocks. The belt of ancient rocks of 2000 million years from Brazil coast matches with those from Western Africa. Okay, the belt of ancient rocks of 2000 million years from Brazil coast matches with those from this Western Africa. See here, the rocks, okay, here, the rocks found here and the rocks found here remain the same. Okay, here 2000 million years old rocks are found, and here also 2000 million years old rocks are found. Okay, the belt of ancient rocks of 2000 million years from Brazil coast matches with those from the Western Africa. That means there was no this Atlantic Ocean. In other words, this South America and Africa was joined together. We are joined together. The earliest marine deposits along the coastline of South America and Africa are of Jurassic Age. Okay, earliest marine deposit means oceanic deposits along the coastline of South America and Africa are of Jurassic Age. That means the same. Okay, these marine deposits are found in this here, and found here remain the same, are of Jurassic age. Jurassic, actually this is the age of dinosaurs, say between 1442 to 208 million years before present. That is known as Jurassic age. This suggests that the oceans did not exist prior to that time. Okay, that means Atlantic Ocean was not there, okay, prior to this Jurassic age. Then another evidence, that is tillite. So what is tillite? Tillite is the sedimentary rock formed out of deposits of glacier. Tillite is the sedimentary rock formed out of deposits of glaciers. So let me show you a photograph. So this is tillite. Okay, this is a photograph of tillite. And so tillite is the sedimentary rock formed out of the deposits of glaciers. The Gondwana system of sediments from India is known to have its counterpart in the 6 different landmasses of southern hemisphere. The counterpart of this succession are found in Africa, Falkland Island, Madagascar, Antarctica, and Australia. See, let me repeat. The Gondwana system of sediments from India is known to have its counterpart, means found, okay, in the 6 different landmasses in the southern hemisphere. Those counterparts of this succession are found in Africa, Falkland Island, Madagascar, Antarctica, and Australia. This Gondwana system of sediments, okay, Gondwana system of sediments, see here, Gondwana system of sediments of India, okay, were also found in these counterparts like Australia, okay, then Madagascar Island, Falkland Island is somewhere here, okay, and what are the others? Then Antarctica, and Antarctica here also. Okay, Gondwana system of sediments from India is known to have found in Africa, then Falkland Island, Madagascar, Africa, then Madagascar, Australia, then Falkland Island, and this Antarctica. So this proves that all these continents, okay, all these land masses were joined together. So it proved that. Overall resemblance of Gondwana system of sediments clearly demonstrate that these land masses, as I told you, had remarkably similar histories, okay, that India, Africa, Falkland Island, Madagascar, Antarctica, Australia have similar histories. The glacial tillite provide unambiguous evidence of paleoclimate and also of drifting of the continents. So it proves that the continents were drifting, the continents were moving, okay. Paleoclimate means ancient climate. Paleo means ancient, okay, means climates were the same. Climates of Africa, Falkland Island, Madagascar, Antarctica, Australia, India will remain the same. And so it proved that the continents were once together, and in due course of time it was moving away. Next we have placer deposits, okay. So placer, actually this word placer is a Spanish word, and it means alluvial seine, okay, alluvial seine. And see here, actually these placer deposits are mainly found nearby the rivers, okay, see here. See here. Here this is a stream, and nearby it we have got placer deposits. Actually, see here from the slopes of the hills, these heavy matrix are slowly washing down, okay, slowly washing down the slope into the stream. Heavy matrix have been washing down the slough into the stream, and the lighter one quickly we note, okay, carried by the this running water, and so it is deposited here. The heavier one, the heavier matrices are deposited here nearby the stream, and that is known as placer deposits. And here this placer deposit contains very precious metals like gold, okay, platinum, like this. So let me show you some photographs of placer deposits. See, this is a photograph of placer deposits. I think you may be seeing these crystals or the balls, okay, of gold, okay, fragments or pieces of gold you may be seeing. So this is placer deposit, and another photograph is here. This is also a photograph of placer deposit, okay. And so let us continue. The occurrence of these rich placer deposits of gold in Ghana caused an absolute absence of source rock in the region is an amazing fact. That means in Ghana, placer deposits of gold are occurred, but the source rock are not found in Ghana, okay. So let us see the world map. Here Ghana is here, and here in Ghana placer deposits of gold are found, but the source rocks are not found, okay. Source rocks are not found. The gold bearing veins are in Brazil, and it is obvious that gold deposits of Ghana are derived from Brazil Plateau when the two continents lay side by side, okay. See here, gold deposits of Ghana are derived from Brazil Plateau. See here, gold deposits of Ghana are derived from this Brazil Plateau when the two continents join together here. That is the point mentioned here, because as I told you, placer deposits of gold are found in Ghana, but the source rocks are not found. That means source rocks are in Brazil, okay. So it implies that the two continents were once joined together. Till now, do you have any question, boys and girls? Do you have any question regarding these evidences in support of the continental drift theory?
No, sir.
Okay, then let us continue. So the last evidence is the distribution of fossils. I think all of you are very much familiar with the fossils. Let me show you some, okay, photographs. See here, this is a fossil of fish. Then here we have another fossil. This is a fossil of plant leaf, okay. And so this is a fossil of reptile, okay. So fossils. Now let us read. When identical species of plants and animals adapted to living on land or in fresh water are found on either side of marine barriers, a problem arises regarding accounting for such distribution. See, when identical means when similar species of plants and animals adapted to living on land or in fresh water are found on either side of the marine barriers, means on either side of the ocean. A problem arises regarding accounting for such distribution. The observations that lemurs occur in India, Madagascar, Africa led some to consider a contiguous land masses, Lemuria, linking these three land masses. That means scientists have observed that lemurs, okay, lemurs occur in India, Madagascar, and Africa. See here, lemurs occur in these India, then Africa, and Madagascar. Then means all these land masses, Madagascar island and India, Africa, okay, were one joined together. So lemur, you know, is a kind of animal. I think you might have seen. This is a lemur. Okay, this animal is found in India, then Africa, then Madagascar island. Okay, see, across India, okay, India is very far away from Africa, then Madagascar is also an island. So here we have a big water bodies, but why lemurs are distributed in India, Madagascar and Africa? That a question arises. So it implies that India, Africa, Madagascar were joined together. Okay, and Mesosaurus was a small reptile adapted to shallow brackish water, and the skeletons of these are found only in two localities. Skeletons of these fossils of Mesosaurus, a kind of dinosaur, okay, are found only in two localities. One in the southern Cape province of South Africa and the Irabor formations of Brazil. Mesosaurus were found, okay, only in these two localities. One is here, and another one is here. Okay, Mesosaurus fossils are found here in the Irabor, okay, Irabor formation of Brazil, and another one is in the Cape province of South Africa. So it means that the two continents were joined together. See, so this is the reptile, okay, this is the reptile that a dinosaur say live in the Irabor formation of Brazil and this Cape province of South Africa. And the two localities are presently 4,800 kilometers apart with an ocean in between them. Now the two localities, that is Irabor formation of Brazil and the southern Cape province of South Africa, okay, say are 4,800 apart with an ocean in between them. That means there is Atlantic Ocean between southern Cape province of South Africa and the Irabor formation of Brazil. That is the point mentioned here. So once the two continents were joined together, at that time these reptiles were distributed, and as the continents move away, okay, so we have got the fossils of these Mesosaurus, one in the Irabor formation, then another in this Cape province. So these are the evidences in support of the continental drift theory. Then the last topic, okay, then forces of drifting, the forces for drifting, that what are the forces that led to the drifting of the continents. So this is according to Alfred Wagner, okay, according to Alfred Wagner, what are the forces for the drifting of the continents? Let us read. Wagner suggested that the moment that the continents were the moment responsible for drifting of the continents was caused by pole fleeing force and tidal force. So these were the two forces that led to the movement of the continents: pole fleeing force and the tidal force. What do you mean by pole fleeing force? The pole fleeing force relates to the rotation of the Earth. We know that the Earth is rotating on its own axis at a very high speed, and because of this rotation, see, it has a bulge at the equator, and this bulge is due to the rotation of the Earth. This according to this Alfred Wagner. See here we have the Earth, and this is the axis, and the Earth is rotating from this west to east, and because of this rotation of the Earth on its own axis, so here it is bulks at the equator. In this way it is bulks at the equator. This is according to Alfred Wagner. Okay, when the Earth was in primordial stage, when the Earth was not solidified totally, at the time due to the rotation of the Earth, the Earth was bulked at the equator due to the centrifugal force. And according to Wagner, this force, okay, this centrifugal force, also known as the pole fleeing force, is responsible for drifting of the continents. See, one more thing I have to say is that, see, this is the Earth, and here we have this equator. Okay, and let me draw this axis vertically, and see, if you compare the distance between the center and the equator, and the distance between the pole and the center, so here the distance between the center and the pole is less, and that is why we have more force of attraction. We have more gravity here, more force of attraction at the poles as compared to the equator. Okay, and that is why objects are, okay, forced to move towards the pole, since gravity is more at the pole. Why gravity is more at the pole? Because the distance between the pole and the center is less, and because of this poleward fleeing force, the continents are, okay, drifting in different direction. This is according to Alfred Wagner. Then the other one, see, the second force that was suggested by Alfred Wagner was the tidal force, and so tidal force is due to the attraction of the moon and the sun that develops tide in the oceanic waters. The second force is the tidal force, and the tide, you know, it is caused by the attraction of the moon and the sun, and this tidal force is also responsible for the movement of the continents. Okay, see here. Here it is like this. So this is the Earth, and here we have a moon, and on the other side we have the sun, and due to the gravity attraction of the sun and moon, okay, see, sea level is, okay, rising periodically, and this is what we call tide. And so tide, you know, these are caused by the gravitational attraction of the sun and the moon, and according to Wagner, this tidal force was responsible for moving of the continent. So this was the supercontinent, and it was broken into two big continents, Laurasia and Gondwana. In the course of time, it was again broken into many pieces, and thus moved in different directions. And this movement of the continents in different direction was due to the this tidal force of the sun and the moon. Okay, gravitational attraction of the moon and the sun. Okay, and boys and girls, do have questions regarding this force for drifting of continents?
No, sir.
Okay, then let us stop here for today. Please don't forget to send your names for attendance. Thank you very much for joining my class.